faithfully conveying value and interpreting great books from around the world. Hi, this is Sally with the Book Talk. Today we're exploring a book called Attention. What do you think is the most important resource for anyone? Is it money? After all, money is just an external thing. It can depreciate or be lost. So, is it time? Essentially, time is just a measure of our lives. It doesn't belong to anyone. So, what could be more important than money and time? This book's answer is attention. What you focus on is what you learn and gain. Anything you want to achieve, be it knowledge in a field or an emotion, requires investing your attention first. But attention isn't like other material resources. It doesn't just sit quietly for you to use. Attention is like a nimble eagle, always scanning around for its prey. Sometimes it stays put for hours, letting us focus intently on work all morning. Other times, it's free spirited, slipping away, or getting drawn in by notifications, leaving us constantly distracted. The author, Jean Philippe, a renowned French neurocognitive scientist, unravels attention's puzzles using the latest brain science and psychology. You'll discover what attention really is. You'll learn what easily captures it and how its mechanism works. By understanding these principles, you can master attention's patterns and better manage your attention resources. All right, let's dive into the book's first and most basic question. What is attention? Most people understand attention based on personal experience, forming an intuitive grasp. You might think attention is the ability to focus on one thing for a while, or when your eyes lock onto something without moving. Only when scientists used rigorous experiments to test attention's impact on behavior did they unlock its mysteries. They found that attention's core is the ability to prioritize some information while ignoring the rest. This information can come from external stimuli or your inner thoughts and consciousness. The phenomenon of attention being drawn by external stimuli is easily observable. That's why scientists first studied the brain's ability to prioritize certain external sensory information. This type of attention is called selective attention. The most classic example is the cocktail party effect. Imagine a noisy cocktail party where an elegant lady seems to be listening to her companion venting. She nods frequently, giving the impression she's paying close attention. Um, but in reality, she hasn't heard a word from her companion, yet clearly catches the gossip from two people behind her. This happens because she chooses to prioritize processing one particular stream of sound among many, the one coming from behind her. Beyond external stimuli, our attention also selects mental processes, internal stimuli, which is far more complex than choosing who to listen to. To distinguish this, scientists coined a new term for the brain's ability to prioritize internal mental phenomena: executive attention. There's a classic psychology experiment called the Stroop task. In this experiment, color words appear randomly on screen, each in different ink colors, some matching the word meaning, others not. For example, the word red might appear in red, while others completely mismatch, like the word black appearing in white. Participants must name the ink color as quickly as possible. To perform this, when seeing black in white, participants must suppress reading the word and instead prioritize identifying the color before saying white. This focused ability to judge color over meaning demonstrates executive attention. Whether selective or executive, attention's essence remains prioritizing some information while ignoring others. So, how does attention choose which information to prioritize? Can we rationally direct attention to process specific information first? With these questions, let's explore the book's second key insight: attention's operating mechanism. When processing information, attention always follows a four-word principle: prioritize what matters most. Meaning, no matter how many stimuli bombard us, attention naturally shifts to what the brain deems most important. You might wonder, what does the brain use to determine something's importance? There are two main criteria: External stimuli and task requirements. First, external stimuli. Human attention gets actively drawn to prominent external cues, like a sudden thunderclap outside your window instantly grabbing your focus. When driving, you'll easily notice red signs and such. But this mechanism isn't unique to humans. Every species in nature shares it. In nature, most flowers and fruits are red because only then do they contrast sharply against green leaves. And so animals and insects can spot them carrying seeds and pollen to aid reproduction, like chameleons and deadleaf butterflies. These creatures desperately camouflage themselves to avoid standing out and getting noticed by predators. But the external environment is complex and ever changing. What stimuli actually capture attention and how? The brain's sensory processing divides simply into two stages: preattentive and attentive. In preattentive, before attentive focuses, countless detector neurons patrol like officers, already extracting and analyzing environmental information. For example, blue here, object moving right there, human face or animal ahead. Preattentive analysis runs automatically in our brains constantly. At this stage, all sensory signals, color, sound, shape, location, or smell, travel via an ascending pathway from the primary cortex at the brain's rear to the advanced cortex in the frontal lobe. This information transfer is called feed-forward processing. Like in detective films, when patrol officers immediately notify inspectors after a crime occurs, and especially striking features trigger attention, launching a second detailed analysis phase, the attentive stage. If pre-attentive processing detects a round red framed road sign ahead, this stage identifies the speed limit number on it. If the previous stage detected a smiling face slowly approaching you, this step should accurately identify whether you recognize them and know their name. At this stage, interactions between the front and rear brain become more frequent, with different brain regions engaging in dialogue. Like in detective movies, where inspectors arrive at crime scenes with sirens blaring, meticulously search for evidence, and question witnesses, many features can capture attention. The most fundamental and common are striking physical features, like color, sound, and brightness, such as a black swan among white swans, an alarm disrupting morning calm, pitch dark nights, or headlights suddenly illuminating a road. Neurons also favor novelty over familiarity. If a neuron repeatedly encounters the same scene, its response gradually weakens. Thus, novel things easily attract attention. For instance, new menu items or freshly replaced Subway ads instantly catch your eye. Additionally, emotionally charged or deeply memorable stimuli readily capture focus. For example, in crowds, we notice angry or sad faces more easily than expressionless ones. As the saying goes, once bitten by a snake, 10 years afraid of ropes. Past experiences heighten alertness to similar shapes. Having covered external stimuli, let's examine the brain's second importance criterion: task requirements. Although attention instinctively shifts to the brightest, loudest, or most pleasing external stimuli, humans have evolved an autonomous control system allowing intentional focus based on task needs, not just instinct. People, how exactly does this work? It primarily relies on our brain's executive system. What does this system do? Its core function is inhibiting habitual responses and flexibly adapting to environmental demands. The executive system, like a broadcaster in our brain, identifying goal essential information and activating relevant neurons and regions. Remember the Stroop task experiment mentioned earlier? Generally, when we see text on screen, recognizing it immediately is an instinctive, habitual response. But in this experiment, the goal is to name the ink color, meaning we must suppress recognizing the meaning and become highly sensitive to color instead. This requires utilizing our executive system. During this task, the executive system essentially broadcasts an instruction. Visual system. Please note, if text is detected, suppress meaning recognition activities. Identify the word's color. Simply put, if words appear, inhibit meaning recognition and switch to color identification. Take driving. Sensory information determining behavior mainly includes distance, traffic signs, and turns. So if the road turns right, you should steer right. If the car ahead brakes, you must hit the brakes and downshift. Beyond reacting to stimuli, the executive system also prioritizes them. Hmm. What does this mean? If driving requires noticing red lights, the brain must develop hypersensitivity during the drive to monitor red light and circular glow features. 88. So, for driving, observing road conditions is paramount. Seat comfort is far less critical. Thus, the executive system prioritizes visual input over tactile and other senses. Focus first on immediate circumstances. However, when a task involves multiple rules or handling several things at once, relying solely on the executive system becomes insufficient and error prone. That's when another brain system, the control system, steps in to assist. The control system is like a firewall running in the background, constantly monitoring, evaluating, and responding to situations. For example, preparing breakfast with bread and knife in hand. Your simple goal is spreading butter on the bread, but your actual attention targets extend far beyond this. You're subconsciously ensuring the knife doesn't cut you, butter doesn't stain the table, and the process doesn't take too long. Your attention is actually distributed across multiple goals. Whenever things go awry, whether conscious or unconscious goals aren't met, the control system instantly detects and reacts. For example, when the knife blade gets too close to your finger, the control system will sound a danger alarm, making you stop immediately. Through learning and experience, the control system also develops strong predictive abilities. For instance, last time you had breakfast at home at 8:30, you ended up late for work. So today, when you pick up the bread slice, the control system will monitor the current time. So if it's almost 8:30, it will remind you to skip eating at home and hurry out the door. It's with the coordination of the executive and control systems, the brain can decide what to pay attention to based on self-set goals. This is attention. To briefly summarize the mechanism operating based on task needs, attention's operating mechanisms mainly have two types. One is based on human biological instinct, where attention is automatically drawn to prominent external stimuli. Additionally, our rationality can call upon the executive and control systems to control attention based on task requirements. And one, so next we'll discuss the final part of the book, how to train attention. We often find it hard to concentrate because the brain is trying to execute a chaotic instruction, mixing several tasks together. And for example, you're sitting at the computer, writing a report while waiting for an important call, but you don't know when the phone will ring. You only know that when it does, you need to conduct the conversation coherently. You see, writing the report and answering the call are two tasks with different goals. The information you need to hold in working memory also differs. You worry that messing up the call will lose an important client, making it impossible to write the report efficiently. Your mind unconsciously prepares what to say. Your brain keeps switching attention from one thing to another, resulting in both tasks being done poorly. Psychological research shows that when switching from one task to another, reaction times slow down significantly. The brain needs to interrupt, deactivate the neuronal activity for the first task's instructions to activate the next one. Activate the neuronal activity for the second task's instructions. This creates switching costs. So, how can we avoid this mutual interference? Next, we'll introduce several methods for reasonably planning attention. The first method is to establish clear boundaries between two activities. For instance, you could roughly estimate when the call might come, leave your computer a few minutes early to prepare, and dedicate that time. solely to the second task. When the time approaches, quickly note where you left off in the report, outline next steps, then confidently pause. With clear boundaries for the first activity, your executive system won't constantly worry about the call, avoiding delays in report writing. The second method involves replacing one task with a simpler alternative. In our earlier example, report writing is complex but well defined, so you can break it into smaller subtasks like brainstorming, subheadings, researching product details, or creating data charts. This way, when the phone rings, you can easily pause the simple task with minimal switching cost. After hanging up, you can quickly start the next simple task. Another approach is scheduling thematically related tasks. For two activities, if they share similar themes, they require comparable information and memory, reducing interference. If client calls are priority, postpone report writing and instead organize client data or meeting notes. This simultaneously prepares you for the upcoming call. With that, we've covered the book's essence. We first established that all forms of attention fundamentally involve prioritizing certain information while ignoring others. Then, through cognitive and neuroscience perspectives, we understood how attention actually operates. On one hand, biological instincts draw our attention to salient external stimuli. On the other, using executive and control systems, we gain autonomous control over attention based on tasks and goals. Finally, we introduced three methods for effective attention management. First, establish clear boundaries between tasks. Second, replace complex tasks with simpler ones. Third, schedule thematically similar tasks to reduce attention switching costs. In modern society, attention is our scarcest resource. Understanding its mechanisms can help you overcome distraction and focus on what truly matters to you. All right, that wraps up our discussion on the book Attention. Key takeaways are below the audio. See you tomorrow.